Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 8.5, Solving Exponential Equations. So for those of you guys who are new to this channel, we post videos like this every Monday to Friday at 3 p.m. Eastern. And if you're somebody who needs tutoring, feel free to click the link in our description where you can get in touch with our team to get yourself some tutoring for advanced functions. But without further ado, let's get straight into it. So this lesson, guys, we're talking about solving exponential equations, okay? Now, the whole point, right, of doing these is to solve for x. Okay, that's what we're doing. When we're solving equations, we're solving for x. Now, a key concept that I want you guys to know when you're dealing with these exponential equations is we want to force the same base. Okay? The way we're going to solve these is we're going to force the same base, because if two exponential functions, for example, let's say 2 to the x is equal to 2 to the 5, if we have the same base, then we can pretty much just make our exponents equal to each other, and that's how we solve for x. So if we don't have the same base, we can't do that. So a lot of these questions, guys, they're going to bait you into this. They want you to figure out what the same base is so that you can solve for just the exponents. So let's go through question one. You know, there's A to F right here. Let's go through it to try and see how this concept makes sense. So let's look at 1A, for example. And you might want your calculator with you. So over here you have 5 to the x is equal to 625. Now I want to make 625 the same base as 5. So in my calculator, if I say 5 to the x is equal to 5 to the 4, because 5 to the 4 is 625, then I can just simply say x equals 4. And there you have it. You got the answer. So this one was pretty easy. Let's go to B. It's a little bit trickier. We have 4 to the 2x is equal to 2 to the 5 minus x. I want to make the same base 2. So I'm going to take this 4 and I'm going to make it 2 squared. And then I'm going to expand out the exponent, so I have 2 to the 4x is equal to 2 to the 5 minus x. And the reason I got that is because I expanded out the exponent right here. Now I can make 4x equal 5 minus x, and then solve for x. I'll get 5x equals 5, x equals 1. So this one, there was a couple extra steps, but same concept, same base. Let's look at number C. We have 9 to the x plus 1 is equal to 27 to the 2x minus 3. So over here, I'm going to make this 3 squared, and I'm going to make this 3 cubed. Then I'm going to expand out my exponents. So I'm going to have 3 to the 2x plus 2 and 3 to the 6x minus 9. And then from here, I can just say 2x plus 2 is equal to 6x minus 9 because we have the same base. And then the 9, I'll bring it over to the other side, so it'll be 11. And the 2x I'll bring to the other side, so it'll be 4x. And then 11 over 4 would give me my x. The rest is just algebra. Okay, let's go through question D. D is a little interesting because we have a square root added in. So first I want to get rid of the square root. So I want to make it base 2. So I'll do it in 2 different steps. So I'll just keep this like this. And I'm going to make this 16 to the power of 1/3. Now, since I got rid of the square root, I'm going to find a base, a common base. So I'm going to be using 2 as my common base. Now that I have my common base, I'm going to expand this out. So I'm left with 2 to the 3x minus 3 is equal to 2 to the 4 over 3. Now I can solve by just taking the exponents 4, and doing it like this. So 3x equals 4 over 3 plus 3. And then because I'm adding a fraction, I have to get a common denominator. So what I'm left with is 4 over 3 plus 9 over 3 is equal to 3x. 3x is equal to 13 over 3. And then from here, 3 will come to the denominator. So it'll be 13 over 9. So this one, a little bit more work, right? Because we had a square root, but the same process. So let's look at question E. E is not that hard. 2 to the 3x equals 1 over 2. So this one we have a fraction on the right side. But this fraction is pretty easy to manipulate. We can say 2 to the 3x is equal to 2 to the negative 1. And then I got 3x equals negative 1. X equals negative 1 over 3. And let's go to F. F is a similar kind of question. You got 4 to the 2x equals 1 over 16. So 4 to the 2x, 16 is 16 to the negative 1. And then I can make the same base. 4 to the 2x is equal to 4 squared to negative 1 because 16 is just 4 squared. So then you get 4 to the 2x is equal to 4 to the negative 2. 2x equals negative 2. X equals negative 1. And there you have it. So the biggest concept, guys, that I want you guys to know is what we're doing is we're forcing the same base. Whenever we're solving exponential equations, we're always forcing the same base. So you got to know, you got to know these things. So for example, 625, 5x. Obviously, some of you guys may not know off the top of your head that, 5 to the power of 4 is 625. But what you do know is that the question is always forcing you to find the same base. So you should know that, okay, it's going to be 5 to the power of something. So then you can do some trial and error in your calculator to figure out, okay, it's 5 to the power of 4, that's 625. So a lot of these, exponents, right, like 5 squared, 2 cubed, 4 cubed, 3 squared, you got to know what these ones are. So let's move on to some other harder questions. Okay, same kind of concept, but we're going to rip through these as well. So let's look at this one. 49x minus 1 is equal to 7 root 7. Okay, so obviously I can tell, there's going to be something with a 7 going on here. But let's first simplify the square root. This is 7 times 7 to the half. So you got 49x minus 1 is equal to 7. A half plus 1 is 7 to the 3 over 2. Now I'm going to make this 7 squared because I want to get 7 as the base. And then from here, 2x minus 2 because I expand the exponent. And then here, I got 2x minus 2 is equal to 3 over 2. So 2x is equal to 3 over 2 plus 2. And then obviously here, common denominator, multiply by 2 and 2. 3 over 2 plus 4 over 2. So you get 2x is equal to 7 over 2. X equals 7 over 4. That one was a little long, but I went through every single step. Let's look at part B. 2 to the 3x minus 4 is equal to 0.25. Now this is interesting because they gave you a decimal in this one. So you got to use your brain here. If you have a decimal, I know that 0.25 is the same thing as saying 1 over 4. 1 over 4 is the same thing as saying 4 to the negative 1. 4 is a base 2. So you see how I'm thinking? I'm kind of going step by step in the process. And then I'll have 2 to the 3x minus 4 is equal to 2 to the negative 2. 3x minus 4 equals negative 2. 3x equals positive 2 because I brought the 4 over. X is equal to 2 over 3. Okay, so that's B. Let's look at C. 1 over 4, x plus 4 is equal to root 8. Okay, so 1 over 4, I'm going to make this base 2. So this is just the same thing as 4 to the negative 1, x plus 4. And this is going to be 8 to the 1 over 2. Now, this one's a little interesting because I need to get this as a base 2. So 4 to the negative 1, I'm actually going to make this 2 squared, but it's to the power of negative 1 to the power of x plus 4. And I'm going to make this 2 cubed to the power of 1 over 2. So notice here, right, this is a little tricky. The 4 to the negative 1, I didn't just put it as 2 to the negative 2 right away. I made sure I put in a bracket to isolate this. And then we're going to have to do a little expansion of the exponents. So here, I can say this is 2 to the negative 2 to the x plus 4, and this is 2 to the 3 over 2. Now I'm going to expand it out and say 2 to the negative 2x minus 8 is equal to 2 to the 3 over 2. Now that I have the same base, negative 2x minus 8 equals 3 over 2. Negative 2x equals 3 over 2 plus 8. Common denominator. Negative 2x is equal to 3 plus 16, which is 19 over 2. And then I bring the negative 2 to the denominator, so I get 19 over negative 4. And that's your answer. So you see, these questions get a little bit longer, right? But mind you, you can skip steps. I don't recommend skipping steps, but you know, for if you're new and this is a concept that you're just starting out with, I would recommend, you know, really writing it out step by step, like how I'm writing it out. Okay? Because when you get to the harder questions, you know, you want to know these little steps. If you feel like you're a bit more confident, you can skip steps, but always be aware when you skip steps, you always expose yourself to more mistakes. So that's something to think about. So let's look at this one. 36, 2x plus 4 is equal to the square root of 1296 to the x. So this one's really interesting, right? You kind of got to use your calculator and some trial and error over here. But this one, it looks hard, but 36, 2x plus 4, the square root of 1296 is actually 36. So that actually worked out in our favor pretty well. Because now that we have the same base, I can just say 2x plus 4 equals x. And then I can say x is equal to negative 4. Because I brought the x over and then I brought the 4 to the other side. So that one wasn't too bad. Let's look at E. E says 2 to the 2x plus 2 plus 7 equals 71. Okay. So this one's really interesting because you have an addition, some addition going on here. So what I would do here is I would say 2 to the 2x plus 2 is equal to 64 because I brought the 7 to the other side. Now that I have 64, I'm going to go and find base 2, which is 2 to the power of 6. And then I just go 2x plus 2 equals 6, 2x equals 4, x equals 2. Cool. And last but not least, let's do F. 9 to the 2x plus 1 is equal to 81 times 27 to the x. Okay, this one's also very interesting. There's a multiplication sign happening. So here, I'm going to actually make this 3 squared for the 9. But the 81, I'm going to make it 3 to the 4. And the 27, I'm going to make it 3 to the 3 x. So it's actually going to be 3 to the 3 to the power of x. Okay, interesting. So here, we're going to have 3 to the 4x plus 2. because I expanded out this guy. And then the other one is going to be 3 to the 4 plus 3 to the 3x. So 3 to the 4 and then 3 to the 3x. So remember, when we have the same base, we actually have to add them. So it would be 4 plus 3x. Now that we have that, and these are just pure exponent laws, we can just go into this and then bring it over to the other side, x equals 2. And all I did here, guys, very simple. I brought the 3x to that side, I brought the 2 to the other side. So 4x minus 3x gives me the x, and then 4 minus 2 gives me the 2. Okay, so these are like a lot of good knowledge questions that are going to help you with this concept, guys. The main concept though, right, the main concept, and I'm going to put it in a box right here, is you got to force the same base, okay? If you're forcing the same base, then everything becomes easier, okay? Now, I want to go through this last question. It's a little thinking question. And this question could be something, you know, I've seen on tests, right? A lot of teachers put this on a test, you know, just to throw you off. But it's a really good question. So let's go through how to break this down. So here we have 3 to the 2x minus 5, 3 to the x. And what I'm first going to do is I'm going to bring the 6 over to the other side. So it's going to be plus 6 equals 0. Now here's what I'm going to do. I'm going to set this up as a quadratic equation, okay? And I'm going to show you how I'm going to do that. I'm going to say let a equal 3 to the x, okay? I'm going to say let a is equal to 3 to the x. Now you see this 3 to the 2x? What I'm going to do is I'm going to say that this is the same thing as saying 3 to the x squared. Okay? And the reason I did that is because I wanted to set up this quadratic equation so that when I plug in a, I'll just have a squared minus 5 times a plus 6 equals 0. Now from this, I can factor this. So I'll get a minus 3 and a minus 2 equals 0. And then once I factor this, what I'm going to do is I'm going to plug in the 3 to the x back into this. So this is going to be 3 to the x minus 3, and this is going to be 3 to the x minus 2. And then I'm going to solve for each one separately. So 3 to the x minus 3 equals 0. That means 3 to the x is equal to 3. And if it's equal to 3, then the power is 1. So then x equals 1, because I just equate the exponents. But from this side, I'll get 3 to the x minus 2 equals 0. So 3 to the x equals 2. Very interesting, because over here, I can actually make this the same base with the 3 and the 2. So how do I solve this? Here, I'm going to have to use my log rules to solve this. So what I would do is I would say, okay, if I log both sides, this is going to become x log 3, because when I log the side, the x will drop to the front, and this will become log 2. Then I can say x is equal to log 2 over log 3. And then you can either leave it like this, or you can put it in your calculator, log 2 divided by log 3, and you get approximately 0.63. So this is an interesting question, right? Being able to change this into this, so the 3 to the 2x into 3 to the x squared is the key concept. And then stating a equals 3x and plugging it in and then solving it as a quadratic. This is a concept that will force you to think a little. No, you may not expect to do this, right? So this is how I want you guys to be aware of this so that when it does come on a test, you'll be ready for it. Anyways, I hope this video meant a lot to you guys. If you found this video very, very helpful, please drop a thumbs up, like, comment, subscribe. It really helps grow the channel. And I'll look forward to seeing you guys in lesson 8.6 next. Bye-bye.